Now, the next question, identify more favorable resonance structure from the following. And we need to justify our answer. Let us talk about the first structure, that is A structure. Now we have here CH3, C double bond O, OH, and then there is a lone pair. Two lone pairs are present. And on the other side, we have CH3, C, oxygen. Here there is negative charge on oxygen, double bond, OH, and here we have positive charge. Right? And then the resonating structure, it is this is shifting here, this is shifting here. After this, we get the resonating structure. Clear? Now, basically, this is the resonance structure for acetic acid. Okay, this is the resonance structure for acetic acid, that is carboxylic acid. Okay, now let us have a look on the left hand side. If I look into the left side, now in left side structure, it is basically what? It is basically a neutral structure. The left side is what? It is a neutral form. Neutral form means it does not have any charge present. Okay, it does not have any charge present. So basically, the carbon double bonded to oxygen. Okay, this carbon and oxygen which are bonded through double bond. Okay, and then we have a single bonded oxygen and hydrogen. Clear? Now on the right hand side, there is presence of. Now, if I carefully look into the structure, the left hand side, it is neutral form. I mean to say, there is no charge present, right? So, the carbon double bond oxygen, and then we have carbon single bond oxygen and hydrogen. That is OH group. Whereas, on the right hand side, I can see that there is what? There is a charge. Okay, it is what? It is a charged form. I'll write down here. Right hand side, it is charged. Clear? Now the carbonyl oxygen, it gains a negative charge, right? Now it is what? It is showing the, on the right hand side, the carbon atom, it is what? The carbonyl oxygen, it is gaining the negative charge and it is being shown by a single bond. Whereas the oxygen, which is attached to hydrogen, this hydroxyl group, on losing its one lone pair, as you can see in the first structure, one lone pair, it is getting converted to double bond. So this hydroxyl oxygen, on losing the lone pair, it acquires a positive charge and it forms a double bond with the carbon atom. Clear? So now we have what? We have a positive charge on the OH group, that is the protonated oxygen, and which is very unstable. Always remember, a negative charge present on a positive charge present on the electronegative element, it is what? It is highly unstable. Now, why is the resonating structure not favorable? Okay, now this structure, it is not favorable. Why it is not favorable? Let us quickly have a look on it. So the structure 1, it is a more favorable resonating structure as compared to structure 2. Now, why structure 2 is not that favorable? Let us quickly have a look on the reasons why it is not favorable. Now, the reason is the positive charge, it is present on the OH group, right? So basically, whenever the electronegative element, it is having a positive charge. In this case, the oxygen, it is electronegative, but it is having a positive charge, especially when it is still bonded to hydrogen. So from here, it implies that the oxygen, it has now only one lone pair left, isn't it? Because one lone pair, it has been shifted over here towards the carbon to form a double bond. So now this oxygen, it has only one lone pair left, right? And it is still expected to form a bond with the hydrogen. So this is energetically high cost configuration. Okay, so energetically it requires, so this is what? This is highly unstable. And on the other hand, charge separation. Now, the resonant form, it introduces a formal charge separation, which is less stable than the neutral structure. Always remember, the charged separation or the structure which is separated by charges, or in the other words, whenever there are opposite charges, then I can say that it is less stable than the neutral structure. Clear? Now, why is it so? Over here, in the second structure, the opposite charges, they are present on the adjacent atom, isn't it? This is carbon, we have oxygen. These are the opposite charges present adjacent. Okay. Now, because of this adjacent carbon atom, now the next question is, identify more favorable resonance structure from the following and justify the answer. Now, the first question, that is A, if I carefully look into the resonating structure, these two are the resonating structures of acetic acid. Okay, that is nothing but carboxylic acid. Now, if I need to answer the question, it is very simple. Structure 1 is more favorable. Okay, it is what? It is a more favorable. Now, why is it so? Very, very simple and very important point I'm going to explain now. Now, always remember, whenever there is a separation of the opposite charge, okay, separation of the opposite charge, I mean to say, if I look into the left hand side structure, there is what? There is a presence of carbon double bond oxygen and carbon single bond OH group, right? So there is basically no charges present or no opposite charge present. So there is no separation of charges in structure 1. No separation of charges. Whereas if I look into structure 2, I can see that there is a negative charge. Along with negative charge, there is also a positive charge, isn't it? And I can see that this OH group, it is containing plus charge. That means the electronegative element, if it is containing electronegative, basically it should have a negative charge, right? But electronegative element, it is containing positive charge, and along with positive charge, it is what? It is bonded to hydrogen as well. So since this oxygen, which is highly electronegative, it is having plus charge, so it becomes what? It becomes a highly unstable. Okay, it becomes a highly unstable. Clear? And since they are present at the adjacent atoms, that is oxygen and OH, okay, these are the adjacent atoms. So definitely it will create what? It will create more and more electrostatic repulsion, and it is not at all favorable. Clear? On the other hand, we have a structure 1 wherein no charges is present. So definitely it will be what? It will get involved more and more into the resonating structure, right? And at the same time, structure 1, clear? So structure 1, it is basically what? It is energetically unfavorable, which lowers its overall resonance stabilization. So basically, structure 1 is what? It is a more favorable resonance structure. Clear? Now let us have a look on the second example, the second question. Again, it is of the similar type. Here we have given CH2, CH, COH. Okay. Now again the same thing. I can see that there is what? There is separation. I'll write down. This is CH2, single bond. Okay. Now this is the, now talking about B structure. Now both the structures here, there is a separation of charges. Okay, I'll write down both the structures. There is separation of charges, right? But if I carefully look into structure 1, it has a positive charge on more electropositive carbon. Okay, we know that carbon atom, it is what? It is electropositive, and then there is positive charge on the more electropositive, whereas a negative charge on the electronegative atom. Okay, electronegative atom is nothing but oxygen. Now, here again, it is what? There is a proper. So thus I can say that the structure is what? The structure 1 is what? It is more favorable resonating structure. Clear? Because on the other hand, I can see that a positive charge is present on the electronegative element, which is again what? It is not at all favorable because it is highly unstable. So simply you need to remember, if a positive charge is present on the more electropositive and negative on the more electronegative, then it is what? It is a most favorable resonating structure. And between the neutral and the charged one, always remember the neutral structure will be more resonance. Okay, it will be favoring the resonating structure. Clear? I hope the concept is clear to you. Now in the next lecture. Thank you.